Hello everyone, I'm Nakaiza Shamim and I'm here to present my topic of real-time detection of malware in Android phone apps using machine learning. These are the contents of the presentation: introduction, problem, etc. Let's begin by the introduction and the background. You find that Android dominates the smartphone market as the most popular mobile operating system, with over 3.5 million apps on Google Play and billions of active devices, making it a prime target for attackers. As seen in our graph down here at damage surge, you find that Android has dominated since 2017, as up to the analysis is up to 2024, but you find that Android is still the best with a very high range. Conventional mobile security methods like signature-based antivirus and static app scanning have significant shortcomings in often failing to recognize new or obfuscated malware. This is because they rely on predefined malware. So in case there is a change in the malware, in case there is a new malware or an attacker makes a change in an existing malware, these methods won't be able to detect them. Hence, machine learning has emerged as a powerful approach to malware detection, overcoming some limits of signature-based methods. Machine learning models can learn malware behavior patterns and identify anomalies indicative of malicious activity in real time, unlike the static rules. Despite their potential, machine learning-based Android malware detectors still face critical gaps. You find that some of the authors who have developed solutions, you find that the solutions are still having gaps. One is lack of real-time response. However much they are using machine learning, you find that they still focus on the static nature, whereby their solutions lack real-time response. Poor resource efficiency, whereby you find that the solutions are heavy, hence poor performance on the phones, slowing down the OS. Minimal explainability, this is whereby they fail to come to a conclusion as to why they flagged as malware, as malicious. Our problem statement goes by: the current malware detection models face challenges below. There is lack of real-time response. This is whereby some models don't focus on solving zero-day attacks. They first wait for the malware to run on the machine. They first wait for the malware to run, and then they detect. By the time they detect, the malware has already affected the OS. Then there is poor resource efficiency, whereby some models are heavyweight, hence slowing down the machine, the OS, the phones, devices. And then minimal explainability in the existing malware detection models, whereby some models can't really explain as to why they flagged as malicious as opposed to benign. Models only stop at detecting malware. They do not provide a solution after malware has been detected. So you find that with some solutions, the moment you use it, if you try to open an APK, they'll just say this could be malicious. They are not even sure of whether it's malicious or not. They just alert. So when you go on to install the app, you end up being affected. So that's another issue of whereby they just alert you, but they don't go into details of why they're alerting. So addressing these issues requires an adaptive, efficient, and transparent machine learning based solution. Under the literature review, I reviewed the paper, which introduced DetectBat as a novel framework that leverages the capabilities of DexBat for app-level analysis, especially tailored for complex tasks of Android malware detection. It adapts to evolving malware threats. So this solution is not static. It adapts to evolving malware, like in case of any obfuscation, it will be able to detect. However, there is no continuous learning mechanism, no explainable AI, no preventative mechanism that they talked about. So meaning they will only based on their data set. Their data set will not they will not continue learning from new incoming malwares, however much they're able to detect. Then another author, Yang Li, He, Zhan, and Zin, proposed a novel method called MDA Android, which detects malware based on self-built functionality API mapping. So the gap here is that they don't consider dynamic analysis because there are no dynamic features used. They rely on pre-collected burn-in apps which are unsuitable for real-time variability. Real-time deployment testing is missing, and also no explainability and interpretability of the model. Some of the objectives are: the main objective is to develop a lightweight, explainable machine learning based tool for real-time detection and classification of malicious APKs on Android phones. Some of the specific objectives are to perform feature engineering from available Android APK datasets, to develop and implement an optimized explainable machine learning model, to design and build at least 10 machine learning models capable of accurately detecting malware in apps, to evaluate the performance and interpretability of the best model among the developed ones, to implement, to audit and deploy a lightweight, best performing Android malicious APK. To audit and deploy a lightweight, best performing Android malicious APK activities detector. So some of our research questions include: one is, what specific app features are most indicative of malicious activities on Android phones? Second is, how can we make the malware detection model's decisions transparent and trustworthy? How do we make sure that the results produced by our model are trusted by the users? Then also, which machine learning model provides the optimal balance of accuracy and efficiency for real-time Android malware detection in apps? Is the model able to explain and interpret its results? Is the model lightweight and fast? Is the model deployed and in use by its targeted audience? Under methodology, the study will employ a quantitative experimental approach using supervised machine learning techniques. Data collection will be from public datasets, that is Android and etc., combined with real-time Android feature extraction. This is whereby during the collection of our data, we got data from Android, but moving forward for continuous learning, we shall keep extracting features from existing apps and adding them to the model for continuous learning. Then machine learning algorithms such as random forest, support vector machine, and deep learning neural networks will be evaluated. Explainability tools such as SharpLime will be used to address the black box nature of the model. So this is the high-level overview of how the model will be built. First of all, we have our data set. The first thing that will be done will be feature selection, whereby we choose the most efficient features that will enable us detect if an app is malicious or benign. The next thing will be feature scaling to get the most appropriate features. Then the next thing will be inputting these features into a model for training. So we shall use various models like k-nearest neighbor, random forests, etc. So at this point, we shall be detecting malware and categorizing. After training our model, the next thing will be performance evaluation, whereby we shall use the we shall use this table, which evaluates the true positives and true negatives. This will enable us in understanding whether our model, how our model performs. Then the output will be a proposed Android malware detection model. So this is the high level overview of how we shall come to our goal. And the project workflow is, the first step is data collection. After getting access to all the data sets that we need, the next step will be feature engineering, where we get the most appropriate features for our detection. Next step is model training. We train the model on the dataset that's available. Step 4 will be real-time classification. Then step 5 will be explainable output. And then evaluation. At the end of the day, we shall have our proposed Android malware detection model. About the dataset, we obtained a dataset from Androzu with over the size of this file, this CSV is 3 GBs. It has many APKs that were flagged malicious. So I'm sure that this will enable us at least gain, let me say, 80% of our detection. It also has APK binaries, meaning on top of the data that it has provided, I can go on and extract features from these APKs to get more data or more features that are missing in the dataset. So expected outcomes and the significance. After achieving our goal of coming up with a lightweight, explainable, real-time machine learning model detector, we expect to have a real-time malware detection. We expect to have explainable and transparent detection, whereby we are sure of how the model came to a conclusion or came to flag an app as malicious or benign. We shall have a wider impact. Users will benefit, cybersecurity practitioners, the Android owners, they all benefit from this solution because it is secure. Then we shall also have improved security with minimal overhead because it's lightweight. So this is the high-level overview of a sample real-time detection pipeline, like when we have already deployed our model, how it will be functioning. So when the user installs their app, I'm assuming that the user already has this model on their phone. When they try to install an app, the next thing will be extracting permissions and intent strings etc. from this app. We extract features from this app. We pass them through our model. From our model will return a score and a classification, and hence flag. So if the app is malicious, it will block and flag it as malicious. If it is non-malicious, it will flag success and the installation continues. Potential challenges and mitigations. So what I expect to face is limited or imbalanced data. How I will mitigate this is by use of multiple data sources to enrich diversity by merging several public datasets and generating additional traffic, since I have existing APKs that are malicious. Another challenge is computational efficiency. Machine learning model might be too slow for real-time use. So how I'll mitigate this is emphasize lightweight algorithms, where if Deep learning neural network is too slow. The simpler random forest may be used as the deployed model. Then the challenge of interpretability versus model complexity. Mitigation is to explain the specific steps the team will take to mitigate this challenge. This is the project timeline. By July, I should have done all the literature review and proposal finalization. I should have finalized my proposal. By the end of August, I should have gathered all the data and selected all the features that I'll use for my model. By the end of September, I should have developed the model and integrated the explainability. By the end of October, I should have done system evaluation and refinement. By the end of November, I should have documented and submitted my thesis. Then by the end of January 2026, we should be in production, users testing, publishing. The model should have been deployed, published, and in use by the intended audience. Thank you very much. That's it from me. These are my references. Thank you very much.